Today we are doing Module 3, Lesson 14, and this is the last module before your weekly check-in tomorrow. Okay, and your learning goal today says, I can use thinking strategies to help me solve multi-term problems. Multi-term problems means that when you add or subtract, there's more than two numbers that you're trying to add or subtract. So maybe there's three terms, 1 plus 1 plus 1, that has three terms. Does that make sense? Or if I say 2 plus 1 plus 7 plus 10, that has four terms, so that's multi-terms. That's what it means. Does that make sense? And today what we're going to be doing is we're going to be looking at how we can use different kinds of thinking strategies, or we can think about the numbers in certain orders that will help us with our solving multi-term problems. Go ahead and write down this problem in your notebook. As promised, is this a multi-term problem? It sure is. How many terms does it have? Let's count together. 1, 2, 3. It's a 4-term problem, which means we have to add 3 different times. Right? We add the first 2 things, then the next one, then the next one. But if you actually look at this, there is some way that you could kind of rearrange those numbers. When we rearrange or change the location of numbers, what property are we using? Commutative property. And let's check though. Is this addition? Yeah. So do we have commutative property of addition? Yes. If it was subtraction, could we change things around and commute things around? No. But this is addition, so we can't. So there's some way, I think, that we can rearrange or commute those terms from one place to another that will make this problem a lot easier to think about. If you see some patterns or have an idea, go ahead and write the problem, commute those terms in your notebook in a different way so that it's easier to solve. Now, when I look at this problem, I notice that there are 2 different denominators. We have thirds, and then we have fifths. In general, I want to always write the same denominators together if possible, because that can help me look to see if there's anything easy to do. For example, I'm going to commute it. I'm going to do 2/3 plus 1/3. Then I'm going to do plus 1/5 plus 1 4/5. What's convenient about this? Well, we can see right off the bat, if I have 2/3 plus 1/3, what is that? 1. And then, if I have 1/5 plus 1 4/5, what is that? 2. And so all of a sudden, I thought at first, oh my gosh, this multi-term problem is going to be so hard to solve. Is it? No. What's 2/3 plus 1/5 plus 1/3 plus 1 4/5? 3. Very good. See how we can use thinking strategies. We can look for patterns and use what we know about benchmark numbers. Like, for example, that 2/3 plus 1/3 will be 1, and it makes it much easier to solve these multi-term problems. Now, we notice this problem is subtraction, so we can't really just commute all the things around, okay? But we can think about them in certain orders. If I start with 5 7/8, and I later on have to take away 7/8, doesn't that just get rid of that? And then I'm done with this, right? And then I'm going to have to take away 1/2, and then I'm also going to have to take away 1 1/2. So altogether, how much do I have to take away from the 5? 2. So this is the same thing as 5 minus 2, which is 3. Be careful. It's a little bit tricky, because even though we're subtracting 1/2 and then we're subtracting 1 1/2, how come we added those to get 2? Well, because if I have to take away a little bit first and I have to take away more later, can I add up how much I have to take away and take that all away at the same time? That's what we did here. So again, we can use thinking strategies. We can use what we know to make the multi-term problem a lot easier to solve. You see that? Great. For this problem, we notice we have addition and subtraction. Yes? Let's talk about the addition part first. If I have 2 5/6 and I add 1/6 to it, what do I get? 3. And then I have to take away 1/3. If I have 3 and then I take away 1/3, how many wholes will I have left? 2. And what will my fraction part be? 2/3. So for this, a lot of it is just thinking in our head, right? But what I do not want you to do is write out just the answer. Do you see how I'm still using markings and circling things and rewriting and using commutative property to show my thinking in my head? Okay, that's what I want to see on your work. If I want to turn these numbers into a tape diagram, here's what I might do. I have 14/3. Okay. Then I'm going to add some amount. I don't know what amount I'm going to add to it. We don't know. That's what we're trying to figure out. Then I'm going to add 9/4. And all together, I have 8 and 11/12. Do you guys see how we can change it from numbers into a picture, into a tape diagram? Now, how could I find this missing number? Well, could I find how much I have all together first? And then subtract that from my total? Go ahead and work on that. It's a lot easier to change your improper fractions into mixed numbers because then you have a whole number part that's easy to think about, and your fraction numbers will be much smaller. Okay, so let's do that. 14/3. Well, how many thirds does it take to make one whole? How many thirds does it take to make one whole? 3. 3 thirds to make one whole. Do I have at least 3 wholes? Okay. How many would it take to make 2 wholes? 6. Do I have at least 2 wholes? How many would it take to make 3 wholes? Do I have at least that many? How about 4 wholes? Do I have that many? How about 5 wholes? 15. It would take 15 thirds. Do I have 15 thirds? So how many wholes do I actually have? 4. And then how many thirds do I have left over? Okay. I have 4 and 2 thirds. And I have to add 9/4. How could I write 9/4 as a mixed number? How many wholes do I have? Show me with your fingers. I would have 2 because how many fourths does it take to make one whole?
4.
How many fourths does it make to make 2 wholes?
8.
How about 3 wholes?
12.
Do I have 12?
No.
I only have 9, right? So I have 2 and that would take away 8 of them. And how many fourths do I have left over?
1.
Okay, now it's much easier to add because I can add the whole number part. What's 4 plus 2? 6. And then I have to do plus 2 thirds plus 1/4. What would my least common denominator be?
12.
Okay. So go ahead and rewrite those using equivalent fractions and tell me what is 6 plus 2 thirds plus 1/4. Once again, I'm hoping you can see if you don't know how to solve these kinds of problems, draw it into a tape diagram. It says I start with some unknown amount. Then I take away 15, take it away. I take away 4.5, take it away, and I'm left with 7 3/5. So how could I find out how much I started with in the beginning, Rahi? Do you see how, in order to find out how much is in my entire piece of tape, I just have to add 15 plus 4.5 plus 7 3/5. Now, we can add the whole numbers part first, can't we? 15 plus 4 is? Plus 7 is? This is 19. And then plus 7 is? 26. So we know the whole number part is 26. What do we have to add now? 1/2 plus 3/5. Can we do that? Not right away, but do you know how to do it? Oh, okay, good. Go ahead and do it.